Okay, if you guys can turn to page 16. Okay, so today we're just going back and just reviewing concepts that we've already learned, and we're just going to work through these 2 pages here, page 16 and 17. I did my work on a separate sheets, but if you can show you able to get everything inside those boxes, that's fine. But if you feel like you need additional room and you don't have paper, you can always grab paper on top of my shelf there. Okay, so let's start with number 1. Number 1. Typically, whenever we're trying to solve for an exponent variable, sometimes you have to use logs, but there are other times when you're able to get the basis to match, and I think that's what we're going to do for number 1. Here, looks like I can just get the basis to match. If I get the basis to match, I can just remove the base and just set the exponents equal. Okay, so number 1, looks like we can get that base 2 to show up. So how can I represent 4 in terms of 2? 4 is what? 2 to the second power. Yeah. Once the bases match, I can remove those and just set my exponents equal to each other. Yep, just get rid of the bases and should be an easy equation to solve. Right? All right, number 2, we probably do want to convert to exponential form, but what should we try to look to do first? Yeah, let's get the log to come together, right? We have product property. All right, product property. If I have log of u plus log of v, I can merge that together to be log of u times v. I can merge the x's together, right? X squared plus 7x. And then get it into exponential form, right? You can either think of it as 2 raised to the powers, and that way you can get the log base 2 to go away, or you can go through that circular form to pick up all the numbers as you go along that process, right? 2 raised to the 3rd power is equal to the parentheses. Now it becomes a lot more manageable, right? There's no more logs, there's no exponent variable. Put everything over equal to each other, but we got to, can we just factor the x out and make it x times x plus 7 equals 8? Right. How do we do factoring? Good. You got to get 0 to show up. I can't. I know this feels easier. Feels like an easier problem to do this, but we can't. We can't do this. We can't do this. Or if that's not a 0, this is not gonna. Set equal to 0. Go through your trinomial factoring steps. Multiplies to be -8, adds up to be 7. And anytime you're dealing with log equations, whenever you get to your potential solutions, you always have to go back and check to see if these are extraneous solutions, right? So they're going, once you find your solution, they're going back into the argument. If it makes any argument a negative expression, then it needs to be removed. It's not a solution that's valid. Okay, so -8 is going to be the one that's not going to quite work, right? -8 and for either, it makes both of these arguments fail, but if it makes even one argument fail, it's enough for us to remove it. Okay, questions for 2? Try number 3. All right, 3 is one of those factoring problems where it's a little bit easier to see if we let that e to the x be something that is more easily recognizable. What if we let x, quote unquote, x be e to the x, right? If I can make it into an easier factoring problem, I can factor that easier problem and then bring my original e to the x back in. You can factor in that form, but it just feels a little less familiar. It's easier to use it to solve an easier problem. Let's do that first, and then we can deal with that e to the x later. So 2x squared minus 7x plus 6 is easier. Go through star method, multiplies to be 12, adds up to be -7. -4 and -3. So once I have my expression in factored form, then let's bring the original e to the x back. Okay, set both parentheses equal to 0. Now we may have to involve log or natural log because we're still dealing with a variable that's in the exponent location. Now I can take the log of both sides, but typically it's a little bit easier and cleaner to take the natural log of both sides because natural log and e have a way of cleaning each other a little faster. So I'll show both ways. If you want to do log of both sides, that definitely works. So if you take log of both sides, the exponent x can come down, and then, sorry, I got cut off by the. And then you can divide both sides by log e. Use your calculator. Log 2 divided by log e is 0.693. Another option is if you're at e to the x equals 2, you can take the natural log of both sides. And that x can come down. The reason why this is a little bit cleaner is because natural log of e is just 1, so I can just make natural log of e go away. And x is just natural log of 2, which is equal to 0.693. So tomorrow we'll do 7 here. So it's up to you. You can do log of both sides, take natural log of both sides. But typically, when I see e in as my base, feeling natural log is a little bit cleaner, but either way works. Whichever way you choose, but sometimes it's easier to deal with natural log. All right, number 4. Okay, how would you start this? I start removing all the logs. Not yet, right? What should we do first? Yeah, quotient probably, right? I need a one-to-one equation before I can take the logs out. So let's merge the two log statements together, right? That's quotient property. Log u minus log v can be log of u over v. Now that I have a one-to-one log relationship, I can remove the logs and then just deal with the argument. Any step along the way, if you want me to clarify anything, feel free to let me know. Okay, so we got a fraction equal to another fraction. I'm just thinking cross multiplying is going to be a little bit easier, or it's a quick way to kind of get rid of my denominator. So I'll do cross product. And we can figure out a way to solve for x. Okay, we got x squared, we got x, we got a constant, and we're going to have to go through trinomial factoring. So move everything over to one side, get 0 to show up on the other side. Multiplies before, assets be -5. -4, -1, solve for x, we get 1 and 4. And both 1 and 4 are good because neither 1 or 4 will cause any of the parentheses arguments to be negative or 0. So we can keep both answers. Okay, number 5. So we always want to at least explore the possibility of, wait, can I maybe get the bases to look the same? But here, 156, can't easily get that in terms of a power of 7 raised to a number. So, it doesn't quite look like number 1 where we can get the bases to match easily. So we're going to have to rely on logs. And so here, take the log of both sides, which will allow our exponent to freely come down. And once that variable comes down, then it's a lot easier. Just divide our way through to get to our answer. So anytime I'm looking for an exponent variable and I can't get the basis to match, I'm going to take the log of both sides. X is now free to come down. Final property. And now it just becomes a multiplication division relationship, right? Divide both sides by log 7, then make the calculator find the decimal value for you. And also with exponential functions, you don't have to worry about extraneous solutions. Okay? You only have to worry about extraneous solutions if your equation starts off with log. Here, whatever answer we get is going to be valid. So number 5, we couldn't get the basis to match, but number 6, we can. What can I do with that 27? 3 to the third, right? Once I get that 3 to the third to show up, I can get the basis to be removed. And I can just focus my attention on setting the exponents equal to each other and solving for x. Again, no need to test your solutions with the original equation because there's, all right, we only do that with logs. All right, number 7. Six natural log of 2x equals 12. Okay, let me ask you, how would you start this problem? 5 by 6. So you know that eventually maybe you got to convert to exponential form, and your goal is to try to solve for x, but you know that natural log 2x is what we want to try to get by itself. So any thing that we can try to clean things up, we're going to try to do that. So there's nothing to add or subtract, but we can divide that 6 over. And now we can just think in terms of, okay, how can I get this into exponential form? Because exponential form will allow us to get into that argument 2x. Right now, it's stuck inside that log form. That's hard to get to. So exponential form will kind of free it up a little bit. So I like to get a better visual by making this an expanded form. How would you rewrite ln? Natural log is same thing as what? Log base e. Yeah. So once I get that log base e, it's a lot easier, right? You can just go through that process, either raise both sides with e as the base, or you go through that process converting into exponential form, e to the second equals 2x, right? Going in a circle and picking up your values along the way. Once I can get that log to be a different form, I'm just trying to solve for x, right? So only one step away, divide both sides by 2. Either leave it as e squared over 2, that's the exact value, but a decimal version, make your calculator do that for you, will be 3.695. Try number 8. Use log properties, get it down to a 1-to-1 relationship, and then you can remove the logs, but yeah, that's right. Yeah, so it's log. All right, so here's number 8. Left side is good to go. It's the right side that needs a little bit of cleaning up. Yeah, the positive term is going to be part of the numerator, and the negative term is going to be where the denominator goes. Now that I have a 1-to-1 log equation, I can remove them and set my arguments equal to each other. I'm going to put that 1 underneath the x minus 3, cross multiply, and solve for x. FOIL, bring everything over to one side, set equal to 0, factor. Oh, I forgot to mention, number 7 is a log equation. So technically, we should have entered that 3.695 in for x to see if it causes any issue. But we're safe, right? There's no negative argument here. So, but I just want to keep reminding us that we do need to check for extraneous solutions. Multiplies to be 20, assets be -9. So that would be -4 and -5. Solve for x, we get 4 and 5. And 4 and 5, we got to check every parentheses here. 4 is good with the first parentheses. 4 is good with the second. 4 is good with the third. 5 is good with the first, good with the second, good with the third. Okay, both solutions are good. Okay, number 9, let's pay attention to this one because it's a little bit different. I know you see that minus sign, you're thinking maybe I need to do some quotient property, but is there anything that needs to be done first? Not quite. Now, if there was no minus log base 4 of x minus 1, then I would say, yeah, I would divide by 2. But is there something else that we can do with that 2? Good, exponent. Okay, so that's where it's going. It's going to exponent. We'll kind of condense a little bit so that we can get log base 4 with nothing in front, and then we can do quotient properties. Yeah, so sometimes that throws students off a little bit. Sometimes you got to deal with that power property before you can jump into the product or the quotient property. Exponent comes up first. Now, okay, now it feels like the previous problem, right? Quotient property. Right, it's a little, right? We know that log form is not going to be a good place for us to solve for that x because x is stuck inside the log form. What would you do next? You could convert to what? Exponential, right? Exponential will allow the x squared over x minus 1 to kind of free itself from that log form. And then we can have a much easier algebraic equation to work with. So 4 raised to the first power equals parentheses. Or you can think of it as raising everything with 4 as a base. 4 to this exponent equals 4 to this exponent of 1. The 4 in log base 4 goes away. You're left with x squared over x minus 1 equals 4 over 1. Okay. Or you can go through this visual process of picking up your values as you build your exponential form. 4 raised to the first power equal to the parentheses. Okay, so then once you're here, it becomes a lot more familiar in terms of an algebraic equation, right? Cross multiply and solve for x. Multiplies to be 4, adds it to be -4. -2 and -2, solve for x, we get 2 and 2, or just 2. Okay. Check for extraneous solution. Is 2 safe with both of our arguments? Yes. Yeah, it doesn't make any argument negative. It doesn't make any argument 0. So 2 is good. Number 10 is like number 9, but without having to deal with that coefficient. So it should feel like number 9. Okay, quotient property first. Exponential form. Cross multiply. Here, there's no x squared getting in the way, so I can just solve for x. Don't have to go through any messy or go through any factoring, trinomial factoring here. Okay, does anybody still need to look at number 10? Good. All right, 11. So typically, when we see a variable that's in the exponent, we want to take a log of both sides, but I think there's a better way to go about this problem, right? What do you notice about the basis? Yeah, so anytime I see a nice relationship with the basis, that's going to be the easier way to go about it. That way we can just completely rid ourselves of the base and just focus on the exponent. So always look to see if there's a nice relationship with the basis. If there isn't one, then we go to taking log of both sides. But here, there's no need to, it's just easier, especially if we can get those bases to just go away on its own. So 27 is 3 to the third power, 9 is 3 to the second power. Just have to worry about distributing those new exponential values through the parentheses, but this should feel like an easier problem without the 3 in the way. Again, once you're dealing with an exponential equation, there's no need to test for extraneous solutions, right? You're only dealing with extraneous solutions if there's a log expression to begin with. All right, number 12. Should feel pretty straightforward with this one. Okay, how would you start this? Exponential. Yeah, there's no like terms to worry about. There's no divisional terms we have to combine. It's nice and ready. Okay, we don't distribute, right? We can't distribute. There's no log property that allows us to distribute through the parentheses. The x minus 6 is kind of stuck in that form. Let's just get into the exponential form. That can allow us to get inside that x minus 6 and solve for x. What's another way of thinking about 4 to the negative 2? 1 over 4 squared, yeah, which is 116. Okay, any questions with 12? Okay. 13 looks a little different, right? Looks a little messier with that natural log, a little messier with that square root. But the hint is that treat it like number 12. Right? Go through the same process like you did with number 12. There's going to be something that's going to be a little bit different towards the end, but in the beginning, it should feel like number 12. So how should we start this process? What would you do first? Natural log, it's easier to if we have it in expanded form. So let's make it look like what? Not base C, right? Same thing, it's easier for us when we can see that base in front of us. Okay, I want to solve for x. X is stuck inside log form, so convert to exponential, right? And e raised to the 0 equals the square root. What's e to the 0? Or what's anything to the 0? 1. What can I do to both sides to get rid of that square root quickly? Yeah, if I square both sides, anything I do to one side, I can do to the other side, and I can freely now work with an equation that has no square root if I just simply square both sides. 1 squared stays as 1, but root 2x minus 4 is really what we want to change. Things have to be just 2x minus 4, add 4. Oh, sorry, I forgot to mention the previous problem. Your answer 97/16. If you insert into the argument, it's safe. So it is a valid solution. I forgot to mention checking for extraneous solutions. And add 4 to both sides, divide by 2, 5/2, which is 5/2. Or you can say x equals 2.5. Okay, 2 more, 14 and 15. Okay, 14 is one of those factoring problems. Let's make that e to the x be represented by x or different variable. Factor the easier problem, and then you can bring the e to the x back. Okay, does anybody still need 13? So if I let x equals e to the x, then create that easier problem, x squared minus 5x plus 6. Let's factor that easier problem, and then we can bring the e to the x back into our equation. Multiplies to be 6, adds it to be -5, -3, and -2. But this isn't the problem that we're solving, right? We want the e to the x. Set both parentheses equal to 0. You can take the log of both sides, but natural log is going to be a little bit cleaner. You kind of have one less step to worry about. So I will take the natural log of both sides to bring those variable exponents down. Okay, I did it both ways, but I did one using log. I used another using natural log. Natural log is a little bit cleaner because you can just wipe the natural log e out. It's a little bit less to plug in the calculator, but those are your two answers. Okay, 15 should be pretty easy. How would you start this one? Exponential form. Yeah. Once you're there, you're easy to solve for x once you're there. But we got to go back and check, right? Got to make sure, double check, and that our solution is valid. Okay. I'll check. Okay, let me check 16 and 17. And tomorrow we'll just do more of the same. Okay, get really comfortable with this.